Hi, today we will review the topic of the security in industrial systems. To start with, let's look at a very important definition. What are safety instrumented systems? Safety instrumented systems are designed to respond to plant conditions that can be dangerous in themselves or if no action is taken. It could be eventually lead to danger. They must generate the correct result to avoid the danger or mitigate the consequence. The acronym SIS means Safety Instrumented System. These are some of the other names in use: Threat and Alarm System, Emergency Shutdown System, Safety Shutdown System, Safety Interlock System, and Safety Relay System. In this figure, the SIS is defined as a process limited by sensor, logic solver, and actuator with interface associated with user and the basic process control system. What is a hazard and what is a risk? A hazard is an inherent physical or chemical characteristic that has the potential for causing harm to people, property, or the environment. In the chemical process, it's the combination of a hazardous material, an operating environment, and certain unplanned events that could result in an accident. Risk is usually defined as the combination of the severity and probability of the event. In other words, how often can it happen and how bad is the when it does. Risk can be evaluated qualitatively or quantitatively. If we can take away the hazard, we shall have to reduce the risk, reduce the frequency, and or reduce the consequence. In this example, we have Len McGrath. He's a hazard and you are the risk. The frequency is equal 6 times per hour, and consequence is bruises. Risk is equal the frequency per by consequence. Don't forget risk reduction. Risk reduction now is the limit bruises to 2 per hour, where more pads. Now risk is 2 per small bruises. Risk reduction is the work of protective measure. In some cases, this will be an alternative way of doing things, or it may be a protection system such as security instrumented system. When we start to design a protection system, we have to decide how good it should be. We need to decide how much risk reduction we need. The goal is to reduce the risks from to unacceptable to the least tolerable. This principle has a fundamental impact on the way we have to design a security system as shown in the diagram. The concept of tolerable risk is illustrated by the following diagram showing what is known as the principle of the ALARP. The ALARP is principle recognizing that there are three broad categories of risk: negligible risk, tolerable risk, and unacceptable risk. Fatal accident rate. This is a method of establishing tolerable level of risk. If a design team is prepared to define what is considered a target fatality rate for a particular situation, it's possible to define a numerical value for the tolerable risk. The generally accepted basis for setting FAR figure is the number of the deaths per 100 million hours of exposure. This can be taken as the deaths for every 10 to the 8 hours worked at the site of inactivity. FIR can be used as the basis for establishing the tolerable rate of the occurrence of an hazardous event. For example, suppose a plant has an average of the 5 people on site at all times, and suppose that one explosion event can causes the death of the one person. And the FIR site have been established as the 2 per 10 elevated to 8 hours. We can calculate the minimum average period between explosion that could be considered tolerable as follows. This example we will review in the assistance sheet.